Hello guys, my name is Dylan, my YouTube channel is DRG Bros, and today we are going to be doing a review of Calculus 3, Joint Proportionality 2. So the topic 1 is going to be a review. So first of all, I just wanted to go over why is this important? Why is this idea important? Because all the formulas in science, mathematics, business, statistics, etc. come from this single idea. There are three types: direct, inverse, and joint proportions. So, for our direct example, we have a person walking down a path. So what we can figure out is that the distance is proportional to the time. So the distance is equal to the constant time. So the distance is equal to the rate time. For our indirect example, we have a person moving a box. So the time it takes to move the box is the proportionate to 1 over the number. So t is equal to k 1 over n. So t is equal to the people 1 over n. So the more people, the faster, the easier it moves. And then finally, we have our joint proportion example, which is the Cavendish experiment. So what we do here is we have this little bar and a wire attached to it with a mirror on. And then we have another bar parallel to this one here. So we have two masses here, M1 and M2. What we could say is that if we put a light here that shines on the mirror and bounces back, forming something that looks like this, if we place a copy of M2 here and a copy of M1 here and make them smaller, so you can see that you can tell the difference, what we get is it will start to rotate, causing this beam to go over here. And so F is proportionate to M1, F is proportionate to M2, and F is proportionate to 1 over R squared. So F is proportionate to M1, M2 over R squared. F is equal to K M1, M2 over R squared. And then F is equal to G, which is 6.67 times 10 to the negative 11th, M1, M2 over R squared. So this is the universal law of gravitation. Now we can move on to our second topic, which is going to be titled Ideal Gas Law. So let's say we have a tank, and so we have a cylinder, and then we have a piston right here. So, and we have four gauges. one of them is, we can measure the pressure, temperature, the volume, and the number of air molecules inside. So yeah, we have our air molecules in here. And so what we can say is that the pressure is proportionate to the temperature. So if we have, for example, take a lighter and we heat it up, then the pressure would go up with the temperature. And if we cooled it, then both of them would go down. So that is directly proportionate. What we can also say, though, is that the pressure is proportionate to 1 over the volume. And then finally, we can say that the pressure is proportionate to the number. And so what we can take from all of this is that the pressure is directly proportionate to the time times 1 over the volume times n. So the pressure is equal to the constant temperature times 1 over the volume times the number. So what we can get from this is that the pressure is equal to RT times 1 over V times N. And so some will rearrange it so you get PV equals nRT. Thank you guys for watching. I hope you enjoyed and learned, and I will see you for another video. Bye.